All right. Hello, everyone. My name is Paweł Skiścim. It's a pleasure to be here. Thank you for the invitation. Uh, I'm the Chief Operating Officer at I4B, which is a software company. And today's presentation is going to be about the testing and simulation techniques and craftsmanship techniques that we use in order to make stable and reliable systems for electromobility applications. Uh, it sounds a bit technical, yeah, but it's in fact going to be I'm going to share some insights, some other thoughts, and some recommendations on how to make a better software solutions for electromobility. Let me say a few words about the company, who we are. We are a software house. We have 60 developers. Originally, we were connected very much with the automotive market, with auto parts market. So we created a lot of enterprise systems for large-scale applications and integrations of car data catalogs and car parts catalogs. And for a couple of last years, we decided to jump into the electromobility, to use our experience in DevOps, in distributed systems, to create stable systems also for EVs. What I always like to say about our team, this is the fact that our biggest value is that we can be pragmatic, so we can choose the solutions that are worth paying for, and on the other hand, we are able to deliver business value. So it's not just coding for coding purpose, but it's a good leverage of engineering and profitability from business perspective. I decided to choose a quote for the start of the presentation. The famous car racer Mario Andretti said once that if you have everything under control, you are not going fast enough. And that's probably a good metaphor of what's happening in the electromobility market right now. Usually we want to be really fast. We want to grow our network. We want to onboard more chargers, more clients, more tenants, and we need to be really fast because our competitors are not sleeping. So if we miss the chance, we can be just out of the business. So we hear very often that any CPOs contacting with us, they say that, now we have just 10 chargers in our network, but next year we're going to have 1,000 just for sure. And well, that's obvious. You need to be fast to be in the business. But the challenge actually is in a proper balance between rapid growth and maintaining the stability. So on one hand, you need to be fast enough to maintain competitiveness, but on the other hand, you should take care of the stability and reliability of your whole platform and your whole solution. Why it's important? You can easily imagine that missing stability can raise a lot of frustration, and this frustration can occur in many places. I remember one of my first journeys with the EV that I made to a skiing resort somewhere in Italy, and then getting back in the middle of the night. I just got stuck on one of the chargers, trying to download the app. The internet connection was not really working. When I finally got the app, I need to register and fill all the forms there. It also was not really user-friendly, and during this whole time, my EV was not being charged. So I wasted already 20 minutes before I actually started the loading process. So that's the EV driver frustration that it's quite obvious, and it ruins the reputation of the whole business. On the other hand, a pissed off driver usually takes the phone and tries to connect to some support line. And on that end, the frustration may happen as well. If the guy from the hotline doesn't really know what's happening or can't reboot your station, or can't guarantee that your money is not taken from your card and you are still not being charged, that's another point of frustration, another pain point. Finally, when you got your card charged and the situation is over, there are still some problems to be solved later on. So probably the CPO or any business owner needs to know how often can it happen and how much money I'm losing actually because of those kind of problems. From the development company perspective, usually developers would say, well, on my end it works perfectly. I don't know why it's not working on your side. So those are the problems where the lack of stability may negatively impact your business. So how to prepare actually for those kind of situations? Usually when you start or when you're aspiring CPO, you can't really imagine the scale of your business. So maybe you don't think too much about the big scale. So you take some assumptions, or you want to be really fast. So you just test the happy paths, and the real trouble comes when there is a real traffic, and that is usually the situation where it's a bit too late to fix something. So yeah, this is why we realize that maybe it's better to take some steps to be prepared for scale. Let me share some thoughts and experiences from the case study that we had with one of our clients. So it was actually a custom CPO's platform with 500 charging points. And the company asked us to join the project to diagnose and to diagnose what was happening there, and to cure, if possible, anything that needs to be fixed. So on our mission, we joined the project. So there was a system developed by internal developers. So we, as an external company, we tried to first figure out what are the pain points. So there were the usual pain points, let's say. So there was poor drivers experience. There were lots of failed charging sessions, lots of transactions broken, or some blocked money, or some refunds to be done, and also a lot of unclear situations of the state of chargers. So the first steps that we usually do in order to diagnose the situation is the need to increase the observability. So we would like to know what's happening and in which places, and actually why. So the natural consequence at the beginning is just to browse the features that are in the platform and then the logs that we have from the platform, but it may not be enough. And in that case, we also needed to introduce some external tooling, like APM and some additional profilers. We use Datadog for those purposes. So then, having all this tooling all together, we were able to correlate the information that we had. So we were able to check the time between the request, the response, the messaging. We were able to identify the bottlenecks of the system, and the first corrective steps that we took was improvement of the auto discovery and auto configuration procedure. So checking which parameters are set in configurations, and how the specific heartbeats or meter values and stuff like that, and play with them a little bit. Then we introduced some self-healing procedures, so like for example, retry policy, and we played with the frequency of the retrials. And apart from that, we add some additional logging and some steps into, for example, payments process or some various business processes that were implemented there. yeah, when those basic steps were done, we were able to focus on some more sophisticated ones, and that one was, for example, shortages in peaks of traffic. So in general, the performance of the system. And here, taking advantage of the previous steps, we were able now to focus on scaling in both vertical and horizontal. So in terms of vertical, we just realized which parts of the infrastructure and which parts in the cloud we could just upscale in terms of RAM and CPU. Then we focused on modularization of the system, and that gave us some possibilities for the horizontal scaling. So we took advantage of some modules that could be, and some microservices that could be scaled horizontally. We introduced some caching of those data that doesn't need the instant access. We were able to cache it, and we also provided some isolation of some particular OCPP connections. So we divided the traffic or separated the traffic from some problematic chargers, and we also guaranteed some more resources to the chargers that were kind of premium chargers. Those were some of the experiences that we had in that particular project, and that made us think, okay, so if we are able to firefight the situation in the system that has 500 chargers, how much is the limit, or would it be enough for a much bigger scale? And that made us think about some considerations to start playing with simulations. We already had some scenarios of, some testing scenarios and some scripting that we used, but we wanted to check it from business perspective. Okay, how much can the system still handle, and what's the threshold of its stability? So we challenged the number of chargers, the number of sessions. We also wanted to know how effectively we can diagnose those problems, right? So if something happens, how quick we are able to react and how quick we are able to find out where's the reason. And finally, we had also some considerations about costs. So getting prepared for large scale and investing a lot in scaling. What are the consequences of the costs of maintenance? That made us think about some kind of internal product or some kind of a set of elements that are reusable for other clients as well. So we decided to create kind of virtual charging network and simulations. So we are able to have kind of a object that has some behaviors, some parameters. It has some scenarios and some pool of connections, let's say. And we are able to make some kind of population of those networks. And then when everything is run in a testing scenario, we are able to generate some heavier load on the e-mobility platform. Some of the scenarios that we consider there are just the basic ones, like the connections, the number of connections and transactions. There are some targeted simulations that were asked or required by our client to check, so some specific behaviors. And we were also trying to play a little bit with some basic security simulations, so some kind of DDoS of the whole network. So how the system would behave in such scenario. Usually when putting your system under this heavy conditions, let's say, the consequence of such action is that you have your technical debt visible. So the technical debt in software engineering is the consequence of any shortcuts that you made on your way. So no matter if it was conscious or it was like taken because of the rapid development, but usually with some time there is still some underdone work or some bugs or some legacy grown together with your business. So it's usually a good moment that we can compare with the pit stop in racing, that you were really fast, but now you need to take some time to recover from what you are doing. And in software engineering, it means that you need to refactor some of the places. You need to give some time for bug fixing or introduce the awareness of what's going on in the whole platform. So from technical point of view, there are some steps or some actions that we usually do in this order that we have here, but not necessarily. But generally, first of all, it's nice to start with the observability. So no matter if you are the owner of the platform or you're using the external platform, you can always incorporate some tooling like, for example, Datadog, and connect your chargers to this tool and be more aware of what's happening, whether that's are the particular chargers of particular producer, or maybe they are in some problematic region, or what's going on there, what are the times, what are the responses, what are the numbers simply in those chargers, and that may lead to some how to say it. You can learn from that simply and have some good proofs, whether it's your physical network or it's the software. Then when you know the weak points, you can try to play with vertical scaling, so adding more CPU, more RAM, no matter if it's in cloud or it's on-premise installation. You can play with your virtual machines there. And that's a bit more challenging, especially if you need to refactor your architecture actually, right? So depending on what kind of layers you have, whether you have microservices, whether you have domain-driven design, no matter what you have there, you need to make it quite easy to have modules responsible for particular subdomains of your operation. And then you can try the horizontal scaling simply by adding some more instances of those particular services. Another idea is to try to switch to asynchronous communication wherever it's possible. So, for example, the OCPP messages that doesn't need to be responded like immediately, then they can be queued, or some system events or some business events that you can process in a bit later time, gaining the time for example, automatic scaling in the cloud. So those are the tricks that you can try to play with. Apart from that, we also try to configure the cache for API services, like the load balancer or API gateways. So those are the technical elements that you can try to incorporate in your system. You can always add some features in the platform, just like the backend features or back office features to make it more visible for your operators or the hotline what's happening. So that's like the very technical perspective for architects or for those who are taking care of the general quality of the solution. From a business perspective, if you are a client or you have an external vendor, simply don't be shy. You can always demand testing for scale. So you should always demand some proofs that the system will do fine when there is more heavy load. You can always invest on your own APM, which is, for example, Datadog. So no matter what tools you are given from your vendor, you can have your own to improve the observability. And then, of course, you should consider the business drivers, so your expectations of growth versus your possibility to invest in a proper solution just from the first days, because sometimes it's maybe not worth over investing. And when you cooperate with a software development team, if the software guys are telling you that there is some debt to be paid, it's worth to listening to them, because it's sometimes it's easy to cure the illness at the beginning rather than at the very end. If you'd like to hear some more about what we are doing in terms of troubleshooting for immobility, we have some services dedicated for the real-time monitoring or refactoring of the systems. We're happy to talk about that at our booth, so please feel welcomed there for a deeper dive of what we do. Yeah, and basically that was all what I wanted to share with you. I hope that was yeah, maybe inspiring, maybe you broadened the thoughts of the landscape of platforms. I hope that with taking care of the reliability and stability, we can make better systems for electromobility in future. Thank you very much, and I'm here for questions.
Are there already any questions?
Hi there. Just interested to know a little more about the load testing tool. Are these very interactive, simulated charge points, and how do you generate the traffic and the transactions?
So maybe let me go back to some screen. Well, so we started with simply, sending requests and responses in a way like you do it when testing the API. But later on, we decided to collect those scenarios and to prepare a tool which has some UI and so options and configurations. So in the tool we have all the messages, the OCPP messages. We have forms where you can fill in the message and simply fire to the station that you want to check. You can do it both in the way of one single charger, but we can also do it in a couple of more chargers, like in the population mode. Usually we need to configure the address of the charger, and then you can do it this way. There's also a possibility to do it the opposite direction. So we always try to use it to test the platform, not the chargers as such. But both ways are possible.
Any other questions? Just raise your hand. Yeah.
Hi. Yeah, just another quick one. You mentioned scaling OCPP connections with API Gateway. Obviously, it's a WebSocket-based connection. Is that on AWS? And if it is, do you have any experience with that versus other cloud platforms for API Gateway and WebSockets?
I think here I would need some help of my colleague, because I was not doing it by myself. But Jacek will answer, I guess. Yep.
Yes, we design a solution to run on the local developer machine, and it's also a cloud version which can create more chargers, basic containers in AWS. Yeah.
Hi, you mentioned integration with Datadog there. Do you have a tool which translates from OCPP messages into a sequence of events that Datadog can receive and then alert on events above or below thresholds?
Yeah, I think we have it. It's not maybe in the UI of this product version of the tool, but we can have it in our scripting. So yeah, in general, yes.
Okay. Are there any more questions? If that's not the case, Pavel, you will be around, right? You also
Yeah.
have a booth?
I'll be around, but if you would like to see any kind of demo or some deep dives, we are there with our whole team, so we can just show you something.
Thank you
Thank
so
you.
much. Thank you.